So let me copy the image over, then we know what we're looking at. Okay. So next we are going to focus on this one. Okay, we are going to focus on our XY plane. Or buckling about the ZZ axis. Okay, so the formula that we are going to use is stress max is equal to P over A. Okay, 1 plus by EC over R squared secant, and then we have pi over 2, and then we have square root P over PCR. Okay, so now remember what we calculate. Okay, the load to be applied is P, which is equal to what we calculate before, is 83.506. Okay, it's equal to 83. Okay. So because the factor of safety is equal to 1, right? So remember we calculate PCR earlier, right? Remember we calculate PCR, but our PCR is equal to P because the factor of safety is equal to 1. Okay. Now this P over here, right? This P over here correspond to this P. This P over here is the applied load. So this situation is like that. Okay. We have calculated P. Okay, we have calculated P for centric loading. Okay, why we take 83.506? Because we assume buckling will occur in the what? XZ plane first. Okay, it is the weaker plane. Or the buckling will occur in the YY axis because it's weaker. Okay, so now we take the buckling about the YY, the load, and put in the eccentric side, which is equal to 83.506. Again, for now, we assume. Okay, we assume. Later on, I'll teach you how to check. Okay, so now we assume that. Okay, so now we know that our P. So what information do we need from here? Okay, what information? So the next thing we have to calculate is our A. So our A over here will be equal to 0.1 multiplied by 0.05, right? So 0.1 times by 0.05 is equal to 5 times 10 to the power minus 3 meters. Our E, which is equal to our eccentric loading. So E is given, so if you look at our diagram, E over here is given to be 0.15, okay, equal to 0.15. Okay. Now, the next one, we have to consider what is our C. Okay, before we consider what is our C, we are going to calculate our PCR. Now, the PCR is in the XY plane. Okay, which is what this is. Okay, so PCR in the XY plane, so it's pi squared E multiplied by IZZ over L squared. Okay, so let's get back to the diagram. Okay, so I'm going to take this diagram again. So we are focused on IZZ. Okay, we are focused on IZZ. Okay, so we know that this is equal to pi squared Young's modulus is equal to what? 73.1 times 10 to the power 9. IZZ, we did calculate earlier. IZZ is 4.1667 times 10 to the power minus 6. The length is the same. Okay, so this is 3 squared. So over here, this will be equal to shift pi squared times by 3.1 power 9 times by 4.1667 power minus 6 divided by 3 is equal to 334.016 times 10 to the power 3 Pascal. Newton. Okay. So from why I do this first, because I want to know IZZ. So when there's IZZ, this distance is our C. Can you see that? Right? So ZZ axis. If without that, you'll be wondering, what is our C value, right? The next thing we need to know what is our C value. So C is equal to 0.1 divided by 2 is equal to 0.05 meters. Okay. So let's take stock. What do we have? We have P, we have A, we have E, we have C. We don't know what is our R. Okay. So our R will be IZZ. So we have to use IZZ is equal to A R squared. Okay. So what we need is R squared. So I'm not going to like square root it. Okay. So R squared is equal to IZZ divided by A. So IZZ is equal to 4.1667 times 10 to the power minus 6 divided by our cross-sectional area is 5 times 10 to the power minus 3. Okay. So this will turn out to be equal to 4.1667 power minus 6 divided by 5 power minus 3 is equal to 833.34 times 10 to the power minus 6. Okay. Okay. Now we have everything. Okay. So from here, we can calculate our stress max, which will be equal to our load is 83.506 times 10 to the power 6. And then we divide by our cross-sectional area, which is 5 times 10 to the power minus 3, bracket 1 plus by E, 0.15, multiplied by C, which is 0.05, divide by R squared, which is 833.34 times 10 to the power minus 6. And then we have secant, right? And then we have pi over 2 square root, okay, square root of 83.506 times 10 to the power 6, and then divide by our PCR in the XY, which is 334.016 times 10 to the power 3. Why I always put 10 to the power 6? 86 10 to the power 3, and then bracket. Okay, so it's quite a handful to calculate from here already. Okay, but break it down. Okay, so what I tend to do this. So 83.506 power 6 divided by 5 power minus 3 is equal to 16.701 times 10 to the power of 80 times 10 to the power of 3. Come on. 83.506 power 3 divided by 5 power minus 3 is equal to 16.701 times 10 to the power 6. Okay. Then 1 plus by 0.15 times by 0.05 divided by 83.34 power minus 6 is equal to 9. Now, when you calculate this, right, make sure you put in radians mode. And to calculate that is basically 1 divided by cosine. Okay, when you press your calculator, pi over 2 square root of the 83.506 times 10 to the power 3 divided by 334.016 times 10 to the power 3. You close the bracket and then you do this. Okay. So again, this will be equal to 16.701 times 10 to the power 6 and then 1 plus by 9. Okay, so I will advise you all start using your calculator now. So cosine, okay, because when I'm teaching this course, some students have problem getting that value. Divided by 2 times by square root bracket 83.506 power 3 divided by 334.016 power 3 close bracket, and the whole thing equal. I'm having a weird number. Oh, no, correct. So cosine. So I get 1.414. Okay, over here. Yeah, 1.414. Let me do it again. Okay, so 1 divided by cosine bracket pi divided by 2 times by square root of bracket 83.506 power 3 divided by 34.016 power 3 close bracket. I think I have to close bracket once or twice. I can't remember now. Once, twice. Okay, close bracket and equal 0.141. Okay, make sure you press your calculator and get it. Okay, or not, it's going to be really worrying. So this will be equal to 9 times by 1.414 plus by 1 times by 16.701 power 6. So the stress is 229. Okay, 229.23 or 238 times 10 to the power 6. And this is less than 414 times 10 to the power 6 Pascal. Okay, both are Pascal. So therefore, structure is safe from buckling. Are we clear? Okay. Now, I know you all don't. It's hard to see or hard to find out if you have used the cal mode on your calculator. So if you look at your calculator now, okay, if you look at your calculator now, you will see a button, right? And the button write CALC. Okay, you see the button CALC. Okay. What I propose that we go for 10 minutes break and then we come back again. Okay, go for 10 minutes break.